This video demonstrates how to add signal control settings to your simulation model. The plan sheet shown on the left will be used in this example to add the existing PM peak hour signal timing settings to the intersection of Bethel Road at Olentangy River Road. This is node 4 in the simulation database. To begin, go to the sidebar Intersections tab, select Edit Intersection Control, and click on node 4. We haven't yet created a signal plan file which will store all of the signal control settings, so we need to create one. In the Input subfolder, create a new file and name it Existing Signal Timings. The option for control type allows us to decide whether this intersection will be stop or yield controlled, or if signalized, whether the controller will operate as pre-timed or actuated. This intersection has variable recall settings at its phases, so we'll pick actuated. TransModeler will assign phase numbers to each of the movements at the approaches to the intersection according to NEMA phasing convention. All you have to let it know is which approach should be assigned phases 2 and 5, and the rest will fill in automatically. In this case, phases 2 and 5 correspond to the eastbound approach, so we'll leave this selection as is and select OK. Once the control type has been selected, several new tabs will appear. First, we'll visit the Phases tab. The table on the right shows the phases at this signal organized into separate columns, with the ID row showing the number that each phase was assigned. The settings that correspond to the operation of each phase are organized into rows. The diagram showing the intersection on the left shows the signal states assigned to each movement according to whichever phase or column is selected. The signal state for each movement at the intersection can be modified by clicking on the arrows corresponding to those movements according to whichever phase is currently selected in the table on the right. For example, at this intersection, all left turn movements have protected permitted phasing. So we'll want to go to the even-numbered phases corresponding to the through movement at each approach and select the left turn at that same approach. Solid green corresponds to protected, hatched green corresponds to permitted. The same selections can be made by right-clicking the arrows and choosing from drop-down lists. Similarly, the pedestrian crosswalk phases can be added in with the through movement phases at each approach. This is done by selecting the link on which the crosswalk is located. Finally, we know that the southbound approach has a right turn overlap phase with the eastbound left turn protected movement. So if we go to phase 5, we can go to the southbound right turn movement, select green, and select overlap. You may have noticed that the right turn red arrows are either dark or lighter colored, which means right turn on red is either allowed or restricted. In this case, we'll assume that right turn on red is always allowed at all of the approaches. Once you've made these adjustments to the signal states, choose Save. Next, we'll fill in the input values for the settings shown in the phases table. First, we can go to the plan sheet and check that phases 2 and 6 are set to coordinated, so we can check the option for coordinated signal here at the top, which will disable the max screen input row and enable 2 rows at the bottom for coordinated and split. So for the coordinated row, we can set phases 2 and 6 to yes. And for the recall mode, we can see that phases 2 and 6 have a pedestrian recall. So we can make that setting change in this drop-down list. And then starting at the top, we'll enter the input values for each phase for minimum green, yellow and red clearance intervals, and extension time. The settings in the detectors row can remain as is for now, and we'll come back to that later. In the pedestrian clearance interval row, most plan sheets like this show the pedestrian clearance and walk times as 2 separate values. In this case, in the phases settings table, those 2 times are combined as 1 input. So if the walk time is 7 seconds, clearance or the flashing don't walk time is 13 seconds, our input will be 20. Next, we'll set the split and the offset. Note that in the plan sheet, these values are expressed as percentages of the cycle length, which is 120 seconds. When the yellow and red clearance interval inputs were updated from their initial default values, their split also updated accordingly, which in turn automatically updated the cycle length. Likewise, if we modify the cycle length from its current value, the splits will all update according to the proportion at which they're currently set. So we can simply enter the percentages that correspond to each split, and we should see the cycle length now should add up to 100. And if we modify that to be 120, the splits will update according to the same proportion they were just set. And then we'll enter the offset calculated to be 114 seconds. So we can save all the inputs for the phases tab and move over to the ring and barrier tab. In this example, the ring and barrier settings as shown here will not be modified, but there are a few items worth noting for future reference. The phases shown here in the ring and barrier table can be rearranged either automatically by selecting a predefined template or manually by modifying the number of rings or barriers, and for an individual cell, selecting a phase from a drop-down list that will replace the current phase. In the graphic shown below the table, the dashed lines represent the minimum green intervals for each phase, and the pointer arrows shown at the bottom of each row represent the reference point. In this case, phase 2 and 6 are the coordinated phases, and the reference point is set to the beginning of the yellow interval. You can also modify the splits for any phase by clicking and dragging the ends from left to right. The phase splits, which are shown here, will automatically update in the Phases tab. Now we'll close the intersection control editor and set the detector assignment settings. To this point, all of the information we needed from the plan sheet has been added to this intersection, so we can set it aside. To add detectors to an intersection, make sure we're in the Intersections tab of the sidebar, select Add Detectors, and click on the intersection. The detectors that have been added have already been assigned length, position, and detection settings based on a predefined template. This template can be modified in the Parameters menu, but for this example, we're going to use the default template that was applied here. Now we'll return to the Intersection Control Editor, go to the Phases tab, and in the detectors row that was skipped over earlier, we can now see the IDs for each of the detectors have already been populated under the phases to which they correspond. So for a given phase, we can go to the diagram on the left, and by clicking on the detectors, the detection settings can be changed. The striped fill style represents call-only detection. The cross-hatched fill style represents extension-only detection. And the solid fill style that's assigned to all of the turning movements represents both call and extension detection. If we go to the cells with the detector IDs shown and select Choose from this drop-down menu, there are additional detector-specific timing parameters such as delay to avoid registering a call for a vehicle that turns right on red. So now that we've confirmed that the detectors were assigned to the correct phases, we'll save the signal timing plan. And then a quick note about the plan start time, which is located below the control type and currently set to midnight. If the timings vary by time of day, you can enter the plans with the same start times that are indicated in the time of day plans if they are known. The plan start times do not necessarily need to coincide with the simulation start times. So in other words, the plan with the latest start time prior to the start of the simulation period will be simulated. And TransModeler will then automatically transition to any additional plans that happen to have start times during the simulation period. You don't need to enter any plans for the periods of the day that don't overlap with the periods that will be simulated. In this case, we can just assume that the start time for this plan in the PM peak hour will be 5 o'clock, which coincides with the simulation period. So we'll click on change and just type in 5 o'clock. And if we want to, we can even rename the plan name. As a reminder, this can be named anything. We call it the PM peak hour. If we want to add additional plans, we would go to this drop-down list and select New. And for example, maybe we have an AM peak hour timing plan that starts at 8 a.m. That plan can either be built from scratch, similarly to how we did here, or it can be based on the same plan we just defined and saved to start with that as a template. If we want to remove this plan, just click Remove here. But for now, we're going to keep the one timing plan for just the PM peak hour. And if we've confirmed these are the settings we want, we can save our signal settings file and close the intersection control editor.